Okay, so carrying on, we're on to part D now. I'll get my pink pen back out. So D, how many terms are needed for the total to exceed 5,000, the total? So when we go back here, we did a summation formula. Okay, so we had 2 plus 7 plus 12 plus 17 plus dot dot dot. Okay, so U of 1 equals 2 and D equals 7. And now we're talking about the sum, the total, the sum. So we're that S formula again. So let's write it down. The sum of n equals n over 2 into 2u1 plus n minus 1 times by d. And we want to know when is the sum exceeding 5,000. Alright, so this is our calculator trick from today's lesson. N over 2 into 2 times 2, I'm going to work that out, 4 plus n minus 1 times by 7. And we want to know when does that sum become bigger than 5,000. Now remember in class we drew a graph of this, but we really don't, we're not too interested in the graph so much as looking at the table of values. Okay, so let's get it done. Document, insert, and insert a graph. Okay, so insert a graph, and now mine's defaulted to f1 of x. I'm going to type in this guy here, the n over 2, the left hand side. Instead of n, I'm going to put x. The little button here on the calculator next to 9 is the menu for the fraction button. There it goes. So x, and I'm going to put a little down arrow to get down over 2. And then, oh, syntax error. Okay, no problem. Let me just try that again. Okay, so I've lost the entry heading. Control G is a shortcut to get it back. Alright, so I think it's just a little bit of a time lag as I'm recording on screen. So let me just click it slowly. Hopefully. Okay, so now X, down arrow over 2, and then side arrow. And then that brings you to the the entry line. And then open bracket, and it's 4 plus open bracket and x minus 1 close bracket, and then times by 7. Okay, so that'll be the graph, and when we enter it, oh well, we can see a bit of the graph now, can't we? Now here on the x-axis are the n values. N is 1, 2. This is all the way up to n is 10. And actually on the y-axis, this is the sum. So this is the sum values that you've been plotting up here. And we will need to go all the way up to about 5,000 here. So rather than messing around with the scale on the graph, we just go to the magic that is Control T. And there you go. Look, we're just going to scroll down. I want to get to 5,000 as a sum. And look, I'm nearly there already. I mean, that didn't take long, did it? Okay, so look, 38 terms takes us to 4997, and then 39 terms takes us to 5265. So basically, we need n to be equal to 39. Now, if you solve this using your calculator, maybe nsolve or the intersection point, you'd get a decimal answer because you'd be looking for exactly 5,000. But that's how we use the calculator to get how many terms. Alright, now let's have a look at might be the final part, I'm not too sure. Write down 2, 7, 17 in sigma notation, but it's plus. Now remember, sigma notation is addition. So to start with, sigma notation, we need to write down the nth term rule. And where is the nth term rule? There he is, look. Okay, so let me just undo that. If I go to my little lasso, I can do that. Grab him, copy him, and then let's just bring him across here. Okay, so there's the nth term rule. Right, so we just put that there, and then we put the sigma around the front here, sigma, and then we've got to feed in the n values. So we need to feed in the n value of 1. Okay, and when we feed 1 into here, what do we get? So if n equals 1, we get minus 3 plus 5 times 1, which is 2. 2 is the first term. When we feed in 2, we get minus 3 plus 5 times 2, which is 7. That's the second term. Okay, And we're going to keep doing that all the way up to some value, so that when we do -3 plus 5 times that value, we get 132 coming out. So let's just have a look at the start again. And we've already got the answer here, haven't we? Because we said that 132 here turned out to be the 27th term in the sequence. So we're going to use that information now in the final part, because we have to add up all the numbers from 1 to 27. And you can put n equals 1 here, and you can put n equals 27 here. Alright, now alternative variations to this. Sigma, for sure, -3 plus 5n. You could have maybe 1 to 27, and there'd be an understanding that the 1 and 27 you substitute into the n in integer values from 1 all the way up to 27. So that's accepted notation. Sometimes I've seen just n equals 1 here. That's fine. And then something a little bit different is actually the letter changes. And so sometimes I've seen sigma -3 plus 5k, k equals 1 to 27, and basically any letter. So let's do another one. I here, -3 plus 5i, I equals 1 to I equals 27. So it doesn't really matter what letter it is. The letter appears in the rule, the nth term rule, and you generate all terms by substituting in from the first considered number to the last considered number. Okay, well, I hope that helps, and let me try and load up on YouTube, and don't forget to subscribe.